All right, so let me go back here for a second. Think. All right, now you can see me. I'm all in my cycling stuff. So let me go ahead and let's see. We'll go desktop. All right, so now can you see my screen?
Yeah.
All right, so let me just kind of pull something up here. Let's see, factor. All right, so you're talking about number one. So let me get that kind of sorted out here and get that written in, so we can kind of see what's going on. So let's see. Let's go over here. Go to this. So you're having trouble picking up which part of it, the focus?
Yeah.
But you're good with everything else, the vertex and everything?
I think so, but I'm not sure if I'm just getting lucky.
Okay. So let's make sure it's not lucky. Now, what about you guys? The rest of you guys, are you okay on the focus on this one?
Yeah.
Yeah? All right, so why don't one of you guys kind of explain, like, all right, here's how we came up with that for the for number one. So how did you, like, what did you start to do so that you came up with this thing?
I use completing the square to put it in standard form.
All right, so like, so how did you do that? Like, you tell me what to write down? I'll write it down.
Okay. I put, let's see. I put I put y squared plus 2y.
Okay.
Then I put equals to minus x plus 1.
Okay, so minus x plus 1. All right, so Drew, are you good on how we came up with that?
Yeah.
Okay, cool. So then, how did you do this complete the square thing?
Well, first I looked at I remember that because it's a y squared, it's gonna open either left or right. So and then you have to divide the 2y. You have to divide it by 2.
Okay, very good. Yeah.
Then you have to square it. To put it into like a perfect square.
Okay, so the 1 is going to go here, and then the 1's going to go there, right?
Yeah.
All right, cool. So then, so when you're saying the perfect square part, you're taking the y squared plus 2y plus 1, that perfect square trinomial, and you're making it y plus 1 squared then.
Yeah.
Oh, okay. And then these two guys over here, the plus 1 and plus 1, they end up giving you 2.
Yep.
So, Drew, you good with that part so far?
Yeah.
Okay. So then what?
You take out -1.
Oh, okay, yeah. So you're going to factor out a -1. And then that's going to mean we'll have an x right there, but then is it going to be +2 or -2? Very good. Yep. So we're going to have this. Now, this number right here, this 1, or -1, we're going to set that equal to, now, is it going to be 4a or -4a?
4a.
Okay, so we set that equal to 4a. And then if you divide everything by 4, we get the -1/4 for a. So you're okay with that so far?
Yeah. Hold on.
Let's come on.
You're using 4a because it's negative.
Well, are we supposed to use... Well, let's take a look at kind of the equation part of it. Is this going to be a parabola that opens left or opens right? It opens left. So you're saying it's going to look kind of like that.
Yes.
Okay. So here's our vertex, just kind of generally speaking, right?
Yeah.
So the focus has got to be over on this side of wherever your vertex is. You okay with that?
Yeah.
All right. So that means we need to move that way. Now my x-coordinate is going to start out from my center, or the vertex part, and then I'm going to move this way, that -1/4 part. So my x-coordinate in my original, so back up here in the vertex, my x-coordinate is 2. Now if I'm going to move to the left 1/4, so that's why I get -1/4. So that was my a value. Now 2 is the same thing as 8/4. And then -1/4. And that gives me the 7/4 part. But since my vertex, the y-coordinate of my vertex right here is -1, this line right here, that's the same thing as y equals -1, so my focus is going to have that same y-coordinate. Because the only thing that's changing is just our x. So that's why we end up with a 7/4 and -1. Does that make more sense now?
What else? So, and your 2 just comes from the 2 with the x, right?
With a vertex on your x, yeah.
So you do 2 minus 1/4.
Yep. Because think about it like this, since our focus is on, we know our parabola's opened up to the left side.
Yeah.
So wherever our vertex is, our focus has to be to the left of the vertex.
Yeah.
So that's why it's -2 minus 1/4. Because we're going to go back closer to the origin.
And the -1 is the opposite of your y, correct?
Mm-mm.
No.
Same thing as your y.
So our y is a constant.
Where are you at, kiddo? Oh yeah, but remember in the when you're doing the HK, it's always the opposite of what's in
Yeah,
here.
so it's the opposite.
Right. So that's why it's -1.
Mr. Muscarella, if we left it as y plus 1 squared equals -1 x minus 2, would that count on the test?
Yeah, absolutely.
Okay, so does that mean like just x equals -y plus 1 squared plus 2?
You could have it in either form.
Okay.
Because it's like saying, you know, here's one way to write the equation of a line, y equals 2x plus 3. But if you solve that for x, you would get y minus 3/2. And that's the same thing.
Then you have the same equation. Okay.
All right, what else you guys got?
Like for the directrix,
Right?
is it this for the directrix? Is it the same distance for the foci but the opposite side?
Yep.
Alright.
Yeah, so that's a really good question. So here, like on this one, we want 1/4 to the inside of the parabola.
Yeah, so 1/4 to the outside.
So we'd go 1/4 to the outside. And then in this case, we would have this dashed line. Ew, that's an ugly dashed line, but you kind of get the idea. You'd have that dashed line right there, and that would be x equals whatever that value would be.
Will we have to find the directrix on the quiz or the test?
Yeah.
So would it matter if you wanted, would you want it dotted or like not dotted?
The directrix, I'm trying to remember. Did we do dotted one on that or solid?
Here. I put solid, but I'm not sure.
Yeah, I think the directrix is solid.
Alright.
What are we talking about? Are we still on parabola?
Yeah, we're still on the parabola. So does that help sort the directrix part out?
Yeah.
All right.
I have a question.
Yeah, go ahead.
So is the directrix, like whatever A is that what A is to the opposite side?
Yeah, let me kind of draw a quick picture here. So say that you're, and this is just going to be a real general sketch. So here's your parabola. There's your vertex. So on this side up in here, from here to here, that's A, and that would be your focus. We know that's our vertex, but then over on this side, the same distance away, that's also going to be A. So that's going to be your directrix. But in this case, so our directrix, now, is our directrix in this one, would it be this kind of line or would it be this kind of line? Would it be vertical or horizontal? So is the directrix on the, because think about it like this, because your axis of symmetry is what divides your parabola in half so that you could take one side and flip it over and it'd be a mirror image. But your directrix is always going to be the opposite of what your axis of symmetry is. So this would be your directrix if you had an up-down one. So let's just kind of do this real quick. If we had a parabola that was like this, our focus would be here, our vertex would be right here, and then our directrix would be right here going this way.
And the directrix just equals A?
Yeah, your directrix is like this distance from the vertex to the focus, that's A. And from here to here, that's also going to be A. So it's the same distance, it's just in the opposite direction of your focus.
Okay, so like for the last problem where it was 7, our A was negative 1 over 4.
Right.
4.
Mm-hmm.
So would the directrix just be 1/4?
It wouldn't just be 1/4, because that was one that opened up this way. And here is our focus right here. So in our coordinates for our vertex, I forget what they were off the top of my head. Let me see back here. Our vertex was at 2, -1. So our vertex was at 2, -1, which means if we're going to go, our A value was, what was it, -1/4? All right, so our A value was 1/4, so we're going to go this way 1/4 to get our directrix. So what we would do is take our x-coordinate, which is 2, so we'd do 2 plus 1/4. And 2 is the same thing as 8 over 4 plus 1/4, and then that gives us 9 over 4. So our equation so we'd move over here to our directrix at 9 over 4, and then what would our y-coordinate be? -1. But with our directrix, so now our directrix is going to be this vertical line. So our directrix would have the equation x equals 9 over 4. Because your directrix is never going to have the same equation as the coordinate that doesn't change. It's always going to be the one that changes.
So the focus is x minus A, and the directrix is x plus A.
Right. Well, and it depends on which way your parabola goes. Because if like on this one, the one that's up here in the top right, so this would be your y coordinate up here for your so that'd be x, y for your vertex. So your focus is going to have x and then y minus whatever the A value is. But then your directrix is going to be x and then y plus, because we're going higher, whatever your A value is. Does that idea make sense?
Yeah.
So, and I know, Drew, because the directrix was one of your questions. Are you okay? Does that make sense on yours?
Yeah.
It does? Okay, cool. One of the which ones?